When we look up at the night sky, one thing immediately captures our attention. The soft glow. The quiet light that seems to decorate the darkness. That light comes from the moon. For thousands of years, the moon has fascinated humanity. It lights up our nights, inspires myths, and reminds us that we are part of something far greater than ourselves. But have you ever stopped to ask a deeper question? Where did the moon come from? And why do some planets have moons, while others have none at all? Here on Earth, the moon is more than just a beautiful object in the sky. It orbits our planet with remarkable precision, creating a predictable cycle that shapes time itself. The moon helps stabilize Earth's rotation. It influences the tides of our oceans. And over billions of years, it may have even helped make Earth a stable place for life to develop. Earth, however, is not alone. Many planets in our solar system have moons, some have just one, while others have dozens. Yet a few planets like Mercury and Venus have no moons at all. So why does this happen? The answer is not simple. Whether a planet has moons depends on its formation, its evolution, and sometimes pure cosmic chance. Moons form from the environments around planets. They are shaped by gravity, collisions, and time. Each moon carries a unique story, and many of those stories are still being discovered. To understand why some planets have moons and others do not, scientists have proposed several key theories. The first major idea is called the co-formation theory. This theory suggests that moons can form at the same time as their parent planet. In the early solar system, young planets were surrounded by disks of gas and dust. As a planet grew larger by pulling in material, smaller clumps of matter began to orbit around it. Over time, those clumps collided and stuck together, eventually forming moons. This process is believed to explain the large, orderly moons of Jupiter and Saturn, moons that follow smooth, circular orbits and move in the same direction as their planet's rotation. In this case, planets and moons were born together. The second theory is far more violent. It's called the giant impact theory. According to this idea, moons can form after a massive collision between a young planet and another large object. This is the leading explanation for the formation of Earth's moon. Billions of years ago, a Mars-sized body is thought to have slammed into the early Earth. The impact blasted enormous amounts of material into space. That debris began orbiting Earth, and over time it came together to form the moon. This theory explains why the moon's composition is so similar to Earth's outer layers. Similar giant impacts may have created other moons elsewhere in the solar system. The third major idea is known as the capture theory. In this scenario, a moon is not born near its planet at all. Instead, it forms somewhere else in the solar system, perhaps in the asteroid belt or the distant Kuiper belt. If such an object passes close enough to a planet, the planet's gravity can capture it. These captured moons often have strange, tilted, or elongated orbits. This theory is commonly used to explain the irregular moons of the outer planets, especially around Jupiter, Saturn, Uranus, and Neptune. In this case, the moon is not a child of the planet, but a traveler that was claimed by gravity. What's important to understand is this: these theories do not cancel each other out. In fact, multiple moon-forming processes can happen around the same planet. For example, Jupiter's large moons likely formed through co-formation, while its smaller, irregular moons were probably captured later. A planet's size, location, composition, and history all determine which processes are most likely to occur. So why don't Mercury and Venus have moons? They are small or located very close to the Sun. Strong solar gravity makes it difficult for moons to remain stable in orbit. Any moon that once existed may have escaped or crashed into the planet long ago. Sometimes, the conditions simply never allowed moons to form at all. Moons are not just silent companions. They are records of cosmic history, shaped by collisions, gravity, and time. Each one tells a story about how its planet came to be. And as we continue to explore the solar system, we are learning that moons may be just as important as planets themselves. The night sky still holds many secrets. And somewhere out there, new moons and new stories are waiting to be discovered.